Welcome back. Our last session highlights the industry perspective. Our STO collaborative program of work is successful because it brings together constituents from across science and technology, government, academia, and industry, to work with the warfighters themselves, leveraging the insights and strengths of each sector. We have 3 exciting speakers with us today to discuss how we can leverage industry to empower NATO's technological edge. This session will again be moderated by Ms. Eaton. The floor is yours.
Thank you. So welcome back from break. Everyone's looking a bit more bright-eyed and bushy-tailed, which brings us beautifully into the last session of the day. We have a treat in store for you today, and the topic of this session is the industry response and leveraging industry. We'll hear about some mega trends in S&T and from 2 major defense industry players. I would like to invite my panelists up to the stage. For this session, we have Andy Wyckoff, Eirik Lee, and Philippe Du Amor. Yeah, Eirik, could you pass water down to Philippe, please? Sorry. Last minute addition, lesson learned from the last panel. It's quite dry in this room. Please allow me to introduce the panelists. Andy Wyckoff is the Director of Science and Technology and Innovation here at the OECD. Andy has been with the OECD for more than 25 years in various positions in science, technology, and innovation. The OECD provides evidence-based advice to governments on policies that support resilient, inclusive, and sustainable growth. And this year, the OECD also celebrates a birthday and has its 60th anniversary of its foundation. The next panelist is Eirik Lee. He's an Executive Vice President of Kongsberge and President of Kongsberge Defence and Aerospace Business Area. He has worked in Kongsberge since 1990 and started his career as a Navy officer. Kongsberge Defence and Aerospace is Norway's premier supplier of defence and aerospace-related systems and solutions. And finally, but last but not least, Philippe Du Amor is the Executive Vice President of Defence Mission Systems at Thales. He's worked for Thales his entire career, specialising in air and defence systems. He has also a reserve officer in the French Air Force. Thales is a global technology leader in the digital identity and security, defence, aerospace, space, and transport markets. It invests more than €1 billion a year in self-funded R&D. And without further ado, I will pass over to the first panelist to provide their brief introduction.
So good afternoon, everyone. And let me just start as a representative of the OECD, welcoming you here to our conference center and associated. I think you were in the chateau earlier today. And it's just a great pleasure to have you here. Our 2 organizations share a lot of commonalities. We both come out of World War II institutions. I work in a building called the Marshall Building. And I think we share some common objectives towards securing peace and promoting democracy and democratic processes. That said, NATO doesn't do economics and we don't do security or intelligence. And so my remarks are far more broad. But I do want to kind of point to some megatrends I see in science and technology that may be applicable to your field. And I would just say one of the first things the OECD did way back in 1963 was produce something called the Fiscati Manual, which is rather obscure, but one of our most translated documents here because it defines and sets out a methodology for collecting R&D, which was a rather new concept back then, had just really first begun to be systematized during World War II. So the 3 trends I want to talk about. First is, no news to this crowd, the Ascent of China. It is quite a change from the norm that we saw post-World War II, right up to the 90s actually, of basically the G7 dominating almost all scientific fields. In our latest numbers, in constant purchasing power parity adjusted numbers, something I can explain at the break, in US dollars, we've seen R&D increase for China by a factor of 10 in 20 years. Truly astounding. The absolute amount spent on R&D surpasses the EU by a wide margin and is nearly 3/4 of the US effort. And when normalized by GDP, which is what we like to do around here to compare countries, the US stands at 3.4%, China at 2.4%, and the EU at 2.2%. Now, there's some measurement error here. I won't begin to pretend when we do this, but it's not just R&D numbers where we see a huge Chinese uptick. It's across their publications, their patents, and their number of STEM doctorates. Okay. The second major trend is more to the appropriate for this panel, which is a mega trend, which is the rise of R&D being funded and performed by businesses themselves. Since the global financial crisis in 2009, businesses have accounted for 3/4 of the total expenditure on R&D performance in the OECD area and been really the leaders in OECD R&D growth. Our more recent firm-level data, which we try to do a nowcast on, shows the pandemic had a very predictable effect with both information communication technology industries increasing their R&D, as well as the pharmaceuticals, which are big tech players. The downturn in R&D associated with this was in motor vehicles and in aerospace, which both got hit a little bit by the pandemic. Now, I want to dig in on information communication technologies a little bit, because increasingly in some of our numbers, it's the tail wagging the dog, particularly as it consolidates a little bit around what's called big tech in the United States, or GAFA here in France. If you don't know what I mean Alphabet, Amazon, Apple, Meta, and Microsoft. Now, these 5 companies in 2021 alone accounted for almost 1/4 of US business R&D. I mean, again, that's mind-blowing if you begin to look at some of the big R&D players in the US. Now, let me put that in perspective. That's as much as the US Department of Defense's R&D budget, and more than all of Germany's R&D, regardless of source. And so these are big players, and they continue to make a lot of money, and they continue to plow it into R&D, which I think is a mega trend to watch. A lot of what they're spending it on, my last mega trend, is on artificial intelligence, which in 2022 means machine learning, by and large, and neural networks. And again, it's very exciting if you're somebody like me who loves to look at what we call general purpose technologies, like electricity or steam, or even something like internal combustion engines. This is a big factor. We don't know how big, there's a lot of hype, but it's clearly changing things, and there's a lot of potential and promise. The OECD has been working on this since 2016, which seems like a long time ago now, where we developed principles for the development and use of AI in 2019 that were approved by our member countries as well as 6 others, 44 countries, then went on to form the basis of the G20 AI Principles under the presidency of Japan. These act as what we would call lines on the road, where we don't try to hamper development in any way, but keep it moving towards socially optimal goals, things as trustworthiness, explainability, and accountability. Principles are nice, but what do they mean in practice? And putting it into practice is where we've put a lot of our effort recently. And by doing that, we have 3 different ways we're looking at implementation. But the most obvious, and one that you might want to look at, is something called OECD.ai. That's the URL. And it's our OECD AI policy laboratory, or observatory, excuse me. And it includes more than 300 policies from 60 different countries, so people can see what each other are doing. But maybe most interesting for this group, and I'll end with this, is it's got a lot of interesting data. And so from that data, we can look at scientific publications in AI, and we can see that basically China, the US, and EU are roughly the same. But what's interesting is the quick rise of India as a fourth major player here in this area, and something to keep track on. We track venture capital, which isn't a bad indicator for looking at where AI is going, and 80% of it goes to two countries, the United States and China. Let me conclude that just by saying that AI is also fundamentally changing the way science is conducted, and it has a lot of ways to go here. But we're seeing a lot of new techniques. One in particular is AI can read all the scientific literature in a particular field, regardless of the language, and then look and study that and look for patterns and develop hypotheses that maybe no one individual scientist could ever come up with. And then these hypotheses can be followed up by research teams. Let me end there and look forward to the discussion. Thanks.
Thank you very much. Yeah, that's really interesting, and also echoing some of the other comments that have come out from the earlier panels and presentations. So a really good wrap up to the day, actually. Eirik, please.
Thank you, and good afternoon to everybody. It's good to be here, and it's what was the person prior to the lunch stated, that it's only us that keeps us from the drinks. So we'll be short. No, I think this is an interesting theme. So I just wanted to start with a background, just to give you some information regarding how Kongsberge looks at this, so we can understand where we come from. Within the last 10 to 15 years, we have transformed the company from being 90% domestic to being 90% export. And we have achieved that in different ways, but for sure, we need to be in the forefront of the technology. We need to have good products. And in order to do that, we have this triangle model between the Norwegian industry, the Norwegian research establishment, and the authorities, the governments, and the users. And this triangle has actually worked out very well. So we establish unique things, we put it like that, for Norway, and that has also been very useful for other countries as well. And as part of this, we don't need to do everything on our own company. We enjoy having partners, both in Norway and abroad. That's very important for us. And we have a huge supply chain of SMEs. And we like to keep the SMEs doing what they are best at. So that has been the philosophy. So all in all, we call this the staying ahead of the curve strategy. And that's one way we have approached this discussion. But then, coming a little bit more into what has been discussed today, we all want technology edge, and we want timing mean faster. And if I summarize for myself, there are two main challenges. We have heard of it already. A huge number of requirements are put on us as industry from the procurement agencies. A huge, we talk about several thousands. And when you have those detailed requirements, it's difficult to do innovation. So that's one aspect. The other one is really long with many procurement processes. It takes many, many years, normally. But it's a process that has been developed over time. It's good, it works. But then we also have other things we need to create faster. So a subset or a more speedy process should definitely be implemented. And I understand why it is so, and I also understand why it's difficult to change it, because this is the way we have worked for many, many years. Many nations do it, NATO do it, and it's a change of culture, but also regulations, etc., that needs to take place in order to overcome these challenges. And there are a few examples that works as well, so it's good to have in the back of mind. But to address this a little bit further, I have three themes I want to highlight. One is what I call closing the technology gap and invest faster and smarter. I think this, and I honestly believe in collaboration between SMEs, between research institutes, also organizations like STO, with startups and other industry. This is an arena where we can exchange ideas and information of what is possible. And I think the earlier we are in the process, the earlier we can establish the best solution and technology that can be used. And I also think it's about, I talked about requirements. What is good enough definitions? So this definition of what is good enough is important. And I think we should have a trend where we look at capabilities and operational requirements instead. And theme number 2, innovation. Well, larger industry also do innovation. We do that all the time. And we have many examples of that. And also, maybe we do it step by step, in a step-by-step manner. But definitely, we play a role in leveraging both internal innovation, but also innovation from startups, SMEs, etc. That is a role we should really take on ourselves. That's important. And also then, by linking the different organizations together, I sincerely think that we can play a key role in innovation for the future. And also, we talked about these processes within defense procurement. We heard about standards. And also, I think that the industry, at least larger companies, can support SMEs, startups in this area as well, to help out with the standards, how to qualify, do the testing, and perhaps industrialization if it's a very new development item that has been created. So this is the place where larger industry can come into play. And then number 3, commercial or civilian technology and the dual use. This is a huge potential. It's the technology leaps are happening within the civilian and commercial business with open architecture and standards. And I think that's why I started with how we did it in Norway. I think it's to elevate this or to succeed with military adaptation of civilian technology. This triangle, golden triangle you might call it, must be used. So, meaning a cooperation between the industry, the defense side, and research. I think we have many areas where we can do this in a good way. And I will stop now soon. I just have 2 food for thought. Sustainable solution. I think some of you participated in the NATO Industrial Forum last year. Completely different setting. But still, I think this sustainability is coming in defense as well. It needs to be addressed. And we could be fast follower. We can have introduced circular economy, but also define technology that can be utilized. Green propulsion, digital twinning, simulation tools, etc. And then the last point here, access to young talents. More and more important. And I think this idea, what you have heard about today, is extremely important. I also think that to establish a young advisory board is a good idea. Because remember that systems we define today, well, the people that are going to use them are 10 years today. So there's a lot of things to think about in that area. So, thank you.
Thank you. That yeah, a lot of food for thought in there, and raising some other issues that have also come up, the dual use and the standards and requirements and procurement, which, yeah, over lunch we had quite an in-depth discussion about the pain point that exists there. So I'm sure that will come up in questions from people in the audience. Philippe, please. Thank you.
Thank you, Jackie. Maybe good afternoon. So I'm very happy to be with you today. Maybe some words about Thales. 2 words about Thales. So we are a dual company, defense and civil business. I think this balance is quite an advantage because for us it's pretty usual to work with the dual use technologies, and this has increased in a certain way after we acquired Gemalto, which was a real asset for us in this field. As you rightly said, we invest 1 billion a year on R&T and R&D, of course, on top of what we receive for governments. So it's a lot. We're really an engineering company, and we develop technologies starting from the fundamental research up to system integration, and it's hardware, software, system architecture. It's really a complete, I would say, ecosystem of technologies. And of course, we have a long history with the alliance, with NATO. We contribute to many STO groups. We work with NIAC too, and so it's something where we are pretty used to. And we're also a company which is involved in all the warfare domains. So from seabed to space, we are fundamentally everywhere. And it has helped us to develop a strong understanding of the, let's say, the new way of making war, I would say. And we have recently reorganized ourselves in order to have, let's say, organization per milieu. I don't know if it's the right word in English. Per domain, let's say air domain, naval domain, and land and air domain. That's very. That's also, it helped us also to understand better about the new way about collaborative combat and having things working together which were not used to work together before. So we are also installed in many NATO countries, and we have again a long history with contract with NATO. I think one of the most prominent was SISAF, when we had at a certain moment many people in Afghanistan. If I come back to innovation, I would like to say 3 things. Our approach is based on 3 principles. One is we innovate for operational efficiency. So what do we want on the other day is to use technology and to innovate for to provide tools to our customers which help them to have a better efficiency. So we have put together a new way of working with innovation hubs and what we call design centers with a specific, let's say, methodology. And there is a constant challenge between engineers and users. We could think that the users challenge the engineers. Sometimes it's the other way around, because the users want to do the same thing better. Engineers have ideas to say, could you do things completely different? And that's very interesting. Second is, we know that we can't innovate alone. Maybe sometimes we think we could, but no, we don't. So we innovate with partners and academics. We support a lot of startups. So in some of our business, we work with startups. We have centers, for instance, of course in France, but also in Canada, in many other countries. Diana initiative for us is of utmost really interest. For instance, in my organization, this Defense Mission Systems, I have permanently 30 candidate doctors, 30, let's say 2/3 of them in mathematics. And that's really interesting. The third thing is that, to close the loop with the users, we manage R&T to develop products. So we don't do only R&T, we are not a university. So it's something which is not always easy. As I said, hardware is very important, software is very important, system architecture is very important, and also engineering methods have to change. with the new technologies, if we keep the same engineering methods and tools we had before, it doesn't work. So it's complete change, not only on the technologies, say the chips, the ceramics for sonars, but also, of course, software technologies. Everybody knows about that, or pretend to know about that, and I don't. But also, for instance, model-based engineering. I know a bit more about that. So that's something which really helps us to develop faster, hopefully cheaper, for our customers. Also, and it resonates to what Eirik has said, we are in a world where we receive call for tender with 7,000 requirements on a contract which is 2,000 pages. So it's not surprised that some SMEs or startups don't want to respond to that. We have crowds of lawyers and contract managers to deal with that. They don't. So if we want to go quicker, hopefully cheaper, we need to change that. It's a matter of how we deal in contracts, how we share risks. We know that, in many countries in defense, and we know that in the digital world, taking risk is normal, failing fast is normal. Mr. Chopin said 9 out of 10 startups will die anyway. So in the defense world, it's pretty different. As you know, it's pretty different. It has to change. I'm going to give you, let's say, some examples, 3 examples of what we're doing, how things changing with new innovation. It's linked with AI, so it's pretty trendy probably. We have developed a concept called True AI, which is transparent, understandable, ethical. It's very clear that we need to know how AI works for critical systems, and this is what we are doing. It's now starting to be operational, and it's being used in many of our projects. I could mention 3 of them, for 2 of them. One is mine warfare, where artificial intelligence helps the operator to detect mines. We developed synthetic aperture sonars, which gives pictures of the seabed, and our AI helps really and multiplies by 3 or 4 the pace of detection of mines by the operator. So that's very interesting. It's now implemented in the UK-French mine warfare program called MMCM. I think there is the NATO Maritime Unmanned System Group, which will come to visit that in our premises. It's going to be demonstrated by the French Navy soon. That's something interesting. Second is ATDR, automatic detection and recognition, both in let's say, optronics and radar. And that's something which is also a great step forward in order to detect smaller targets. This gives me really, if you look at the complete ecosystem, there is something interesting is, we'd say hardware, software. Okay, we have now developed a lot of new technologies to process massive amount of data. Great. You say a sonar. If you look at the sonar of 5 years ago and now, the throughput, it was kilobits, it's terabits. Same for electronic warfare. Why could this happen? It happened because we developed hardware, which does that. Samplers, 2 gigahertz samplers, ceramics. This is hardware. And why can we develop this hardware? We can't develop this hardware like we developed the previous one. We couldn't do that because we can use simulation using supercomputers. So there is it's completely integrated between software, hardware, and system integration, system architecture. The system architecture has to be different. So it's complete, everything has to change. From the contract, system engineering, system architecture, simulation, hardware, software. If we miss one of these bricks, it doesn't work. This is what we try not to make, not to miss any. Of course, the next step for us, it has started, it's quantum. I'm by history, I'm an RF engineer. I'm thrilled to see that we will have soon a big like that antenna which can detect 50 hertz. that's going to be a big change. So we'll see what's going to happen. No more example. I could give many others. So we see that we are working hard to in order to provide better systems to our customers, quicker, cheaper, and this is all with this ecosystem of innovation that we can try to do that better.
Thank you so much. So I had all three speakers with their golden triangle. We have Philippe's hardware, software, system architecture. We have Eirik's government, industry, and research agency triangle. And we have the three mega trends: Ascent of China, rise of private R&D, and the AI development. And given the time, I want to open directly into the audience for questions rather than giving my own. Yeah, I thought that might happen. I've got one at the front here and then one at the side there.
Hi, and this may not be a fair question, but I'll stand up. Because it's by the way, thank you very much for talking about requirements. I couldn't agree more. Government puts way too many requirements on developers. We went through a session with industry and we didn't talk about supply chain fragility. And we didn't talk about supply chain fragility the rest of the day. Right now, I've heard everybody say we want to go to AI. The best AI in the world will take state-of-the-art computer chips. North America and Europe produce 0% of state-of-the-art chips, and will not for 5 years. We don't even have to worry about just state-of-the-art. The global auto industry last year took a $210 billion hit for lack of a 45 nanometer chip that was produced in Taiwan. We've progressed that to rare earth elements where we do not have the capacity in the West to make things we need for heads-up displays, high-end magnets, and out of the military domain, we don't have access to pharmaceuticals or active pharmaceutical ingredients. At what point does the technology-industrial intersection have to identify supply chain fragility and spend technology dollars to create different solutions?
Okay, I can contribute to this one. It's very clear that here we have a big issue. It's very clear. There are some areas where our customers spend money to make sure that there was a sovereign solution. Can I give you an example? High power amplifiers for the radar of the Rafale aircraft. Everything from research to integration is done in France. If we had accepted, if the French government had accepted to do things in Korea, Japan, it would have been much cheaper. But they spend the money not to do that. Many other examples in France, in the UK with submarines, very, very similar. For the chips, which are more, let's say, more general use, FPGAs, or that kind of thing, it's certainly a very big issue. But I'm afraid, goes beyond defense industry. You know, I would be crazy not to say that it's a big risk that we, the countries, the governments, the armies, it's I don't know the word in English, a Damocles sword. You get it. Sword of Damocles. Sword of Damocles, which is above our head, for sure.
Yeah, I agree with what you're stating, and it's becoming it's a wake-up call for everybody. what we are seeing now with the pandemic and what's going on in Ukraine and how this impact our supply chain and in general. And we find different ways, but it doesn't really solve the fundamental problem. So also we definitely see what is described there, especially on the electronic component side. And the lack of that. You can read something now that is positive, but you never know before you see it. So I think it's difficult to come with a good solution, except that now we have seen it. We need actually to work on it on a high level, on government level, how to be more protected towards this kind of situation again in a global supply chain.
Okay.
I would just make one observation. If we see a problem and we don't have a solution, that is the place for the technology community to take a different look.
Yeah, absolutely. And I think we also had the warning call from our young scientists who pointed out the national resilience was critical, and this talks to that wider issue, I think. I had a second question on this side.
Yes, thank you. Lieutenant Colonel Savai from the Hungarian MIRA from Brussels. So somehow my question is also connected with the supply stuff. In the past weeks, we have seen that due to that fact, the Russian attack on Ukraine, many countries decided to increase the budget spending. They are changing, replacing, modernizing their equipment. And my question is related to that one, that how do you feel that would the defense industry be able to support all those emerging needs? And the other question is that should it be probably done in a coordinated manner? So if the industry is able to support those needs, should it be done in a coordinated manner?
The answer can be only yes. The question is, how long do we need? If I refer to history tells us everything about, in the First World War, Second World War, about ramping up defense industry capabilities. It's in the books. If the technology is not the same, all the rest is the same. I think in 1940, President Roosevelt, let's say, decided a new law, the Seven Seas Naval Expansion Bill, to build a navy which was bigger than all the navies in the world. It took a number of years to make this happen, to make half of this happen, by the way. So really, yes, we can do it. Yes, it will take time. It will take time. If you want to build more airplanes, more ships, you need to build, let's say, docks. You need to build buildings. You know, sometimes you have to build to buy machines that come from other countries. What I'm afraid of is that our customers think it's going to be immediate. No, it's not going to be immediate. But of course it's feasible. In a coordinated way, maybe there will be areas, ships, where there will be shortage, and then it's maybe up to our, let's say, governments to coordinate themselves to see how it can work. You know, we are only humble industry people.
Okay, humble. That was nice. No, I agree. It's a good question. It's difficult to answer, but I would also say that I have seen examples where we are able to also find other solution redesigning, and so it's not all black. So I think it's a little bit case by case as well, even though we have a general view as you describe it. But I wouldn't say it's completely dark in the sense for everything. But if you can be able to coordinate it, I don't know, but that could be one way to approach it.
Okay, I have another question in the center here.
So, Sergio Galeano from Oecd. First of all, thank you very much for the panel, your intervention, very interesting panel. My question concerns procurement. So we talk about sharing risk, huge requirements, large contracts. So from the industry perspective, which changes do you think that could be implemented in procurement process to facilitate collaboration between the private industry and international organizations, and to foster technological development between both sides, whilst respecting the internal rules and instructions of NATO's or other international organizations? Thank you very much.
Yeah, I can go first. Probably different approaches, but the one that pops up in my mind is actually to take existing processes and just, you know, transform it into an easier way for some applications. The problem saying that, because it sounds simple, the problem is that this is what we have been doing for many, many years. So this is like changing a ship direction towards something easier. And keep also in mind that there is kind of a risk associated with this. We know the process we have today. If it changes, then that might be seen as a risk because you bypass something. So I will also think that that's also play into this. But I think the solution is to find just make a simpler acquisition process, but willingness to take on the risk as well.
Maybe one thing to add. Of course, in the contract, there are many things we won't change. You know, there are safety requirements, there are all that. Now, ESG requirements, this won't change. It's not our aim to change that. Now, when we develop a new system, we take risks, and because otherwise we don't innovate. Huh? We discussed that earlier today. If we never fail, we are not innovative. So it's a matter of better share risks. So we promise that performance. Currently, we have many contracts. If we are not at that performance, no acceptance. Sometimes you could say, okay, between this range, it could be decided with the, let's say, with an incentive. It happens. In France, we had some contracts where, after long negotiation, we managed to have it was more about time. We could say our committed time is this date, and we get an incentive, small incentive, if we are, let's say, 1 year or 6 months earlier. So it's that kind of thing which helps us to be, otherwise, you know, if we are dead, if we don't match the requirements, match our commitment, we take margins. So we take risk provisions, price goes up, we take less slack time, and time schedule is longer. So it's more that kind of thing that sometimes it can help, I wouldn't say that it never happens. We wish it would happen, let's say, more often.
Maybe one more thing is to add. I mentioned it, but this the detailed requirements. When talking to the user, that's another perspective. What ends up in the requirements? So it limits the industry's ability to create their own solution, but actually satisfy the end customer or end user. I mean, so that's also a challenge to look into. How can we transform a detailed requirement as of today to be more of a capability or a I don't know, user-defined specification that we have some maneuver to solve, because then we will be able to explore different options in that.
Thank you. I do have a question. Andy, could you talk to us about the trends and challenges you're seeing with S&T policy that is coming out, and then maybe Eirik and Philippe could comment on how that's affecting their industry?
Sure. Well, in general, governments are under a lot of budgetary pressure. COVID didn't help. It's not helping. And so one of the first things that gets a lot of pressure is the R&D spending. That's one of them. But one of the things we're seeing, and I don't know if it's well understood, is there's two ways to fund R&D by and large as we look at it. There's the direct funding that I think you're very well aware of, contracts, grants, and awards, and it was just being talked about. But that is dwarfed by indirect funding, which is R&D tax credits, which become very popular across most of the OECD, and in some countries are a factor of 2 or 3 more than the direct. And so one of the things I think that's going to happen as we face large challenges, whether it be geopolitical, climate, or pandemics, is a swing back maybe to more direct funding of R&D, which would probably be a good thing for most of the people in this audience. As I said, the nature, and you've talked about it, Philippe, the nature of science and technology is changing with digital tools, allowing us to do things we could have never thought of doing, whether it be big data, quantum computing coming, hopefully, but even more simple things such as very sophisticated but cheap sensors that feed the big data flows in more of a real-time communication. Well, we're seeing this certainly on the civilian side. But I guess the last thing I'd like to bring up, which I alluded to in my earlier remarks, is I think maybe the increasing importance of scale. And this is part of, particularly in the digital area that I know best, there are high fixed costs, but then very low marginal costs for a lot of this technology. And so what that really benefits from is if you have a large domestic market, it allows you to get over those fixed costs and then go to the world and kind of what's called winner take most in the digital area with some of the marginal costs. And so with that, I really implore Europe in particular to become more of a single market than it has been in the past for some of these technologies that I know best, and begin to match the size, the scale of the United States and China.
Obviously, I agree that scale is very important if you want to reduce costs, no doubt about that. We all know that, let's say, scaling up the market, say, cooperation, in the defense business, there is cooperation between industries and cooperation between states. Which is the one which goes faster than the other? It depends. It depends. So we have good cooperations. I mentioned mine warfare between UK and France. Mine warfare cooperation went very well between the states. And cooperation went very well between industries because it was Thales on both sides. I won't mention cases, but you see in the press cases where cooperation between states is something, cooperation between industries or amongst two industries is another thing. So it's something very complex, something very complex. And we know that some countries, to give you examples, good cooperation between France and Belgium on, let's say, land vehicles, a good cooperation between Netherlands and Germany in navy ships. So there are very good examples, but honestly, it's very complex story. Of course, if there was only one supplier for everything, for each of the systems, then cooperation would be obvious and price would probably go down. But I'm not sure we'll be there in the next month.
Yeah, but on the other side, I think this type of cooperation is essential, and we definitely have. It's difficult, but we definitely have good examples of where that has been achieved, both between, call it bilateral, between the governments, and also between the industries. It's a matter of finding a path where we actually have, at least when it comes to the industry, find a win-win situation for both industries. And I have several examples, and the latest one is between, for instance, Norway and Germany when it comes to common procurement of submarines. So that's one example where we also the industry, based on the government-to-government relationship, the industry found each way to cooperate. So that's one way.
There are many good cases, but there is no general case.
Agree.
Thank you. I think there's time. Is there?
Yeah.
I think there's time for one more question.
Quickly.
A quick one. Yes, please.
Yes, thank you. Rudy Preem, again from the NATO Industrial Advisory Group. We talked about percentages, and so Andy talked about percentage of GDP. And I was wondering, at the European Defence Agency, since 2007, 2008, they came up with other benchmarks, and not only the 2% of GDP that should be spent on defense, and then 20% of it should be spent on investment in equipment, including R&D. So there's no percentage on R&D specifically, and we are in this science and technology environment. When I look at the European Defence Agency in 2007, 2008, they also had a number for research and development, and they said that 2% of a defense budget should be spent on R&D. If we say 20% including R&D, some nations might cut on R&D and spend 20% on new equipment. So the question is, shouldn't we advocate in this science and technology community for a percentage on R&D, also at NATO, not only for EU member states or European Defence Agency participating member states. So to come up with a percentage, a minimum that should be spent on R&D within the defense budgets, because the private sector is already spending a lot.
Honestly, I don't know. I think it would be good to know where we are, where every country is, because we would probably see big differences. You know, if everybody is at the same number, almost at the same number, setting a target is not going to be too difficult. If there are big differences, I'm afraid there are, then which target should we set? That's not an easy one. So I don't have a good answer to this question.
Yeah, I don't have the percentage, but the idea is good. When it comes to R&D, it's important, and I think that could also trigger common procurement. So I think there should be some initiatives to actually do that.
Andy, do you have anything to add?
I would just say we try to track these numbers, defense spending of R&D, not within the NATO budget, but within different countries. But it won't come as a surprise to anyone in this room. It's pretty hard. Some of our reporting is spotty. Some countries don't. And some of it comes as classified. And so we have dark spots, but that data is available.
So, strangely enough, as a NATO insider, I have an answer. One of the questions that I put into the S&T section of the Defence Capability Planning Survey in 2016-17, roughly when I was in Dale's position, was specifically that, because I was absolutely shocked that we didn't have that information for the NATO nations, and I had the same question you did. I was like, why are we asking 20% but we're not measuring this R&D spend? So some of the nations answered it and some of them didn't. So we also have patchy data, and also it was only asked for 6 years ago, I think. But I do think there is also something interesting when you look at the NATO nations and their capacity for R&D, and it's similar dynamic that you achieve with industry. So when you have a small company, they don't have much money they can put towards R&D potentially, because they need to be producing profit from everything that they're investing. And we have a similar kind of dynamic within NATO, with larger nations and smaller nations and different focuses. And so it could be an interesting question as to, if NATO were more coordinated regarding the R&D, whether it could be having some nations that were R&D specialists, which had very high percentages, and other nations which were producers, which had much lower percentages. So I'm not sure that a single common denominator for that R&D investment would make sense across the NATO nations. Sorry, apologies. I know it's not my job to answer questions. With that, I think we'll probably call it a day, because otherwise I will make it end late today. So I would like to say a huge thank you to my three panelists of this panel. Another really interesting, fascinating discussion, and a lot of food for thought to be taken away from this. And many issues that were even brought up during this panel we didn't even get time to investigate or to look at in more detail. So I'm sure there'll be lots of conversation over cocktails in a moment. So thank you.